Okay, so today we're looking at simple harmonic motion again. So a particle moves with simple harmonic motion so that the acceleration is given by, now this is our acceleration formula here, I just couldn't be bothered typing it. Determine the displacement after t seconds. So the other information that would be given to us in the question is that x is equal to 2 root 2 when time is 0, and the initial velocity is also negative 6 root 2. So first thing I'm going to do is I'm going to calculate our value of W. Okay, so I'm just going to chuck it in this formula over here, and now I can start rearranging to solve for W on its own. So if I took this x over to this side, they would cancel out to be 1. If I take that negative to that side, that will cancel out as well. So now I'm left with W squared is equal to 9. So then W is equal to plus or minus the square root of 9, so plus or minus 3. Okay, next thing I'm going to do is I'm going to throw all of this stuff into our formula here, and this is going to help me calculate the value of A. So, negative 6 root 2 squared is equal to 3 squared bracket A squared minus 2 root 2 squared or bracket. Okay, now I'm going to expand my brackets and get an answer. So, here, this step here is important, and we're going to come back to him later on to talk about something. So 6 times 6 is 36. Square root of 2 times, squared is just 2, is equal to 9. A squared doesn't change, minus 2 times 2 is 4, times 2 again is going to be 8. Okay, so now we can take this across by dividing, meaning that I'll be left with 4. 4 times 2 is 8, is equal to A squared minus 8. Take this to the other side, and we're going to add 8.
Happy Friday, everyone. This is Kaya and Mana from Year 9. Today's shout-out goes to Shane.
That's going to be annoying in the video. All right, so then A squared is equal to square root of 16. So A is equal to plus minus 4. Now when I put this back in... Okay, so now when we put this information back in to our original function, we're going to let x equal 2 root 2 when t equals 0. Okay, now it doesn't matter whether you pick sine or cos, it'll all come out in the wash. I'm going to pick sine because why not? Oh my God, shut up. So this is the formula that we're going to be using. Okay, and now because we're given this, later on this is going to have an effect to what we're putting in as our angle. Okay, so substitute all of your fun bits into your fun formula. Okay, and that's going to give you, this will come to the other side by division, so root 2 over 2 is equal to sine of some angle. Okay, so now that we've worked that out, we've got to work out the exact value, the angles that would make this statement true. So sine is positive in this quadrant and this quadrant, meaning that it is 45 degrees and 135 degrees. Now, if I convert these into radians, because most of these questions will ask for radians, it's going to be pi over 4 or 3 pi on 4. Okay, so now we've got this. We've got to check which one it's going to be. Which one is going to make this statement correct? Okay, so all I'm going to do is I'm going to throw the first one into the formula. I'm going to derive it so it's equal to velocity, and so I'm going to make it equal to this and check that the left-hand side matches the right-hand side. So if I take the derivative of this function here, this is going to come to the front and multiply our A value. So it'll be 4 times 3, which is 12. Sine will change into cos, bracket 3t plus. Now we're going to put our first angle in. So we're checking the pi on 4. I'm checking this one first. Okay, and that should all be equal to negative 6 root 2 because once I've taken the derivative of the position function, I get the velocity function. So first thing I'm going to do is I'm going to take this over to this side, divide it by 12. Boom, that gives me negative root 2 on 2 is equal to cos. Now I'm going to let t equal 0 as well. So it's going to be cos just pi on 4. Cos of pi on 4 is root 2 on 2. This is negative. This is positive. They don't match. Therefore, not pi on 4. So now we're going to check the other function. We're going to check this one, 3 pi on 4. So minus 6 root 2 is equal to 12 cos 3t plus 3 pi on 4. Okay, this is equal to, again, take this over first, I'm going to end up with minus 2, or minus root 2 over 2 is equal to cos, we let the t equal 0, meaning that this is cos 3 pi on 4. Now that is over here in the quadrant where cos is negative. So that's going to be negative root 2 on 2. And this will also be negative root 2 on 2. Therefore, alpha is equal to 3 pi on 4. Now, I'm not finished yet because the question asked me to determine the displacement after t seconds, meaning that I have to put this back into my function. So x with as a function of time is equal to 3 sine 3t plus 3 pi on 4. Now, one more thing that I want to touch on before we move on is how this looks graphically. So because this velocity function is negative, that means that I should be looking for a graph where its position is going down at that first bit. So here's what those functions look like. So this one here, if you look at what's happening after we take the gradient at this point, the gradient is increasing, meaning that it would have to be a positive value. If I look at the other function that was correct, the gradient is decreasing from that 0 point, meaning that that will give me the negative value. So graphically, I could have determined which one it would have been. The other thing to point out is sine and cosine graphs are the same. It just has a phase shift. So if you'd chosen to do this using cosine, you would have got a different answer here, but it still would have worked out in the end. Now, stop recording.